everyone. And tonight we have Karen Wright. She returns to give us an update on the Washington Bee Atlas, a year in review. Karen Wright's research has included native bees and flower phenology in arid systems, bee systematics and evolution of diets, and phenological ecology. Karen is now the pollinator taxonomist with the Washington State Department of Agriculture and oversees the Washington Bee Atlas project. So tonight, Karen will present a summary of challenges, adventures, and successes of the second year of the Atlas. The program has experienced incredible growth in membership between February and April of 2024, ending the year with 160 members. Karen is still pulling together a reference collection of all the bees known to occur in and around Washington and is making progress on identifications. With the invaluable support of volunteers, the Native Bee Atlas has made significant progress, including the record of 8 new species and a creation of an annotated checklist of all bees in Washington state. Please tonight type your questions into the chat and we will address them during the presentation and some at the end as appropriate. Please welcome Karen Wright.
Great. So thank you for having me, and I'm going to share my screen now. First of all, I'm going to just start with a little review about what the Washington Bee Atlas is for the newer people that are coming here, and for some of you folks who aren't really aware of what we do. And if you have any questions, just either pop them in the chat or feel free to speak out. So what is the Washington Bee Atlas and what do we do? Well, our goal is to map all 600 species of native bees in the entire state of Washington and to create county lists of bees and their host flowers, assess their relationship with the plants, and to find out what time of year each species is out because it differs between each species and even in different habitat types. And then once we have all that data together, then we can really truly assess the habitat requirements of each individual species of bees. And the species level really does matter because every species is different for what they pollinate, what soil type or vegetation type they require, what elevation they live at, what plants they pollinate, and what time of year they're out. So until we have all that information on every single species, we won't have any idea of what their conservation needs are. So we're really focusing on all the native bees and hope to work with fish and wildlife in the future. So how are we going to get all this done? Well, one person can't collect all 600 species of bees on over 3,000 species of plants, over 70,000 square miles in every month of the year that bees are active. So we've developed a community science effort called the Washington Bee Atlas, and this is modeled directly after the Oregon Bee Atlas. They've been going strong for 7 years now and have really, really perfected the way that they obtain the data, the quality of that data, and how they train the volunteers to do all this. Because most of our volunteers don't have a science background at all. And so entomology is not rocket science. Everybody can learn it. So what we do is we use the Oregon State's Master Melitology program, which is an online learning platform to help train our volunteers. And then after that, we follow it up with some in-person training throughout the state at different times of the year throughout Washington. So we are also working on developing a reference collection. I'm based out of Yakima, and so we're building a reference collection at WSDA that will help me identify all these species to the species level. So I'm trying to develop a reference collection right now of all species known to occur in Washington, British Columbia, Idaho, and Oregon, so that we can get an idea of, when we're finding new state records and stuff like that. But even though we host a reference collection with WSDA, we work really closely with WSU and their insect collection, and all of our specimens eventually will be deposited at WSU. We also host microscope sessions. Now, not all of our volunteers are interested in this part of the process, but many are. And so you can just go out and collect bees on flowers and go, oh, there's a pretty flower and there's a cool bee, and then your job is done. Or you can get more involved and learn to identify bees to the genus level, and sometimes even further to the species level by attending these microscope sessions. So this past year, we were able to hold several different microscope sessions and really get a lot of education out there, hands-on. So far, we've grown really, really fast. In just less than 2 years, we're up to 162 volunteers, and I think we just got 3 more this week, so we're still growing. In 2024, 67 volunteers collected at least one bee. And together, those volunteers put in over 2,000 hours of volunteer work on the Washington Bee Atlas. We collected a total of 17,000 specimens on over 600 unique plant hosts, according to iNaturalist. So for most species of bees, except for bees in the genus Bombus or bumblebees, most bees, it's very, very difficult to tell which species it is by photographs alone. You have to see each bee from many different angles, and they're really, really tiny, so it's hard to get in focus pictures of the teeny, teeny, tiny guys. So we do lethal collection of the bees. So this is just showing our volunteer growth. We started last year in February with less than 20 people involved. And we slowly grew and grew and grew. But then last spring, between February and April, it was a tremendous amount of growth. So it's really been amazing to see how many people are really passionate and really want to help collect this data. The volunteer hours over each month seem to peak in June and then sort of peter out by the end of the year. And we still need to keep some folks excited about collecting in September and October. Even if you only have rabbit brush to collect off of, there's still some really interesting fall bees out there. This is where our volunteers live at this point in time. We have representatives from not quite every county, so we still need to recruit some folks from the less populated counties. All these people down here at the bottom are people who live in Oregon and are part of the Oregon Bee Atlas, but because bees don't see boundaries, these volunteers don't either. So they come and help us collect up in Washington, even though they live in Oregon. Most of our volunteers are, well, about half and half. Half of our volunteers are retired folks, and half of the people are working or have other occupations. So what did we accomplish in 2024? Well, this is one volunteer's collection, but I will also mention that that single volunteer is the one who collected the most bees of any volunteer. In total, we got 17,000 specimens. And as of now, most of our volunteers have turned in their collections, and I've been able to sort them all to genus and identify all of the easily recognizable species. I'm still working on growing our reference collection and species level identifications for the more difficult bees, which is most of them. And then after we get all those species level identifications, then we can do the data entry, and that data is made public for conservation biologists and other folks to be able to use. So this map shows the growth of the Oregon Bee Atlas. They started in 2018. And so this map shows the growth and how they were able to really fill out the knowledge of bees in their state. And we joined the group in 2023. And so just very slowly at first, but then more rapidly, you're going to see the state of Washington and our other sister bee atlases fill themselves in. And so we still have a big ways to go. We still have a lot of gaps in the map. And we still have a lot of this. We certainly have not uh, done a thorough job yet of knowing where each species live, when they fly, and what they pollinate. So we're going to keep working on that. And for a little bit here now, I want to go over some of our cool finds. And this actually covers 2023 and 2024. For now on, I'm just going to keep track of each new year. And of course, our cool finds might start going down as the years go by. But one really cool find is Melisodes nigricata. And you can tell this Melisodes apart from all the rest because the scopal hairs on the hind legs are actually dark brown or black. They're not blonde like all of the other Melisodes. And so this one is, you can't tell in this picture because, well, she's got it filled with pollen, so it looks yellow. But this is definitely a new state record. They were collected by Autumn Most. She caught, I think, 5 females and 1 male in Chelan County. And this is, if you look at the map, this is a huge range extension. And I even went down to Oregon to see if maybe they had some in their collection and they just didn't know what they were. And I didn't find any in the Oregon collection. So I do believe this is a really strange disjunct um, uh, distribution. So I went even further and I found out where in other collections where the original description of this species, where those specimens were kept. And I had to borrow the original paratypes from Kansas and they mailed them to me and I could compare them directly to the specimens that we had on hand and confirm that, yes, indeed, they were Melisodes nigricata. So that's a really neat find. So congratulations, Autumn. And you're going to see her name pop up again and again. uh, and I should also mention that Autumn was a graduate student when she was collecting all this data. So it's a really good contribution to the knowledge of bees in Washington. So another really cool find that may not be that rare of a bee is Diadasia nitidifrons. And it is a Malvaceae specialist. They're small for Diadasia. And a lot of times you can find the males sleeping in the flowers curled up around the pollen. So Ed found these in Yakima County on, I believe this is on the left photo there, is the genus is Elamnia. And there's a researcher in Utah who strongly believes that if you look at this map over here, that these are actually 3 different species. That there's a far Pacific Northwest species, a California species, and a Utah species. But we're going to have to use DNA and some other trickier things to really figure that out. So I found 1 specimen of Ashmeadiella sculleni right in my own yard. I don't have any photos of this bee, and it's a fairly rare bee. And then coming back to Autumn's finds, she found a really neat bee called Duphoria dilatipes. And if you look at the hind leg, the tibia is completely triangular, which separates it from the other Duphoria species out there. And they also have the males at least have some strange things protruding from their undersides. So this is another new state record that Autumn found during her graduate work, and all of her work was done in Chelan County. And so this is another really great find. It has been collected in Montana, and up in British Columbia, but never before in Washington. Dianthidium cressini is another one of autumn's new finds. And this one is a super neat bee. If you look at the tergal, which are these segments on the abdomen, you can see they're really, really blown up around the edges so that each tergal end sticks out to the side. And so this is a really neat, really cool big bee, big for Dianthidium. Another new state record. And then we also found Dianthidium singulare, which is very similar. It's in the same subgenus, and it also has inflated tergal segments there, but not nearly as huge as the other species. And also, this is a much smaller bee. So congratulations yet again to Autumn. And as we're on an autumn track, she also found Osmia cyanionitans, which is a fairly typical looking osmia. This was verified by Terry Griswold, and it is a new state record. So another bee that is fairly rare, meaning that there are less than 20 records in Discover Life for this species, is Osmia indiprensa. And Carla, Lisa, Ellery, and Nancy all found at least one specimen of this species in Kittitas, Yakima, and Okanagan counties. So it's a fairly rare bee, but I have a feeling that as we're collecting more and more data, we're going to find out that maybe it's not so rare in Washington. Osmia cara is another example of a very disjunct distribution, that it's found in central to southern California and Mexico, and then skips Oregon, but then it appears again in Washington. This is not a new state record because it has been found once before, but Nancy Carlson collected this one in Okanagan County. Lisa Robinson collected the first Zylocopa virginica for the state. And these are a very big, very obvious bee. They tend to be even bigger than bumblebees, and they have a very, very faint blue metallic reflection that comes off of them. So Lisa got this one in Benton County. I believe somebody reached out to her and said, hey, I have this really weird big bee that's living in wood. What is it? And it turns out to be a carpenter bee. But you can see this crazy eastern distribution, and then all of a sudden we find one in Washington. Carla found Dioxys aurifuscus in Grant County. This is a new state record, and it's also a very rare bee. It is a parasitic bee, and those tend to be collected less often than the pollinating bees. So this is another really great find and a very, very beautiful bee. Lasioglossum buccale. This is a weird one. It is introduced from Europe, and it appeared in the Pacific Northwest not too long ago, but we don't have that many records of it. But again, now our volunteers are starting to find it all over Washington. So I'm beginning to believe that it's really established itself in the state of Washington. So Ingrid, Ann Bulger, Jason, and Alex all collected this in 4 different counties. Oh, and this one is very easy to tell apart from all the other Lasioglossum because its head is super elongated. And I couldn't get a frontal picture of this, but when you see it from the front, you'll get how different it is. Another rare bee that Nancy found in Grant County is Lasioglossum aspelurum, which we just don't see many records of it. And there may be more of this species that just haven't been identified laying around in collections. Also, I couldn't find a picture of this one. Glabreventre we don't have that many records of it, although it has been collected by at least two of our volunteers, as well as a graduate student that I'm working with, who have found them in Chelan and Kittitas counties. I'm going to give the credit for this bee, Epulis olympialis, to Ingrid, because she was the one that led a bunch of other volunteers to this spot to find this bee. This is a cuckoo bee, and it's a parasitic on Calidas bees, the cellophane bees. And there aren't, even though it looks fairly widespread on the map, there just aren't that many records for them. But Ingrid found us to a lovely, led us to a lovely area where the Calidas were nesting, and we managed to catch quite a few specimens. Stelis herinae is a new state record, again collected by Autumn Moss in Chelan County. This one was also verified by Terry Griswold. And those of you who know who Terry is, he is the premier bee taxonomist in the entire country. And yet another one for Autumn, Coleoxys funerarius, a new state record that she found in Chelan County as well. So all these bees she collected in bee traps. So she didn't hand net them. She set out traps for her graduate work. Some other cool finds that may not be as rare as we thought they were. Lisa, Ingrid, Ben, and Nancy have all collected Biastes in several counties, but it seems to be a narrow strip on the east side of the mountains going down in central Washington. And this is another parasitic bee, and it has a very strange end to its abdomen with these two triangular points that stick out. So it's really easy to identify apart from other small parasitic bees. All right, so for this year, those are our Rare Bee Awards. So if you're watching here and you are one of these people and you haven't gotten your little Rare Bee pin yet, let me know and I'll put it in the mail for you. So congratulations to all these folks that collected rare bees in the past 2 years. This is very important information so that we know where they live and what kind of habitats we should think about starting to conserve. So we still have our future goals of doing both bee DNA to figure out our taxonomic problems with certain species that we don't know really what they are. And we also want to start this year taking pollen directly from our bee specimens and running the DNA on those to find out not what plants the bees are nectaring on, but to really find out what plants they're feeding their babies the pollen of what plants, so that we can start making some better seed mixtures for each ecoregion in the state. And this is all due to all of our volunteers who aren't scared of running around looking like a crazy person with a butterfly net and are willing to go to some of the most beautiful parts in the state to help us learn more about the bees. So I don't think that was quite an hour-long talk, but I'm hoping that we have some time for discussion and talk. Maybe some of you have some questions about our methods. We're always looking for more people to become part of our group. And you don't have to know anything about entomology to get started. And anyway, that's my story.